Let's see if I was right. I had a student the other day that had virtually the same problem. And when I went to divide by it, I encountered something strange that I didn't know how to handle. And then I thought about it for a little bit, and I realized I think I know what I have to do. What do you suppose it is? You know how we have to put dummy variables in? If we call this the divisor and this the dividend, or the numerator and the denominator, well, if we're missing a power of x, we have to put in a dummy variable, right? A 0.
Yeah.
Well, I think the solution to doing this problem requires putting the dummy variable in here. So instead of dividing by x squared plus 1, you divide by x squared plus 0x plus 1. And let's see if that doesn't solve the problem that I had. I didn't actually go back and do it on paper, but I figured this had to be the way to do it. So what goes here? I didn't mean 0, I meant
7x.
Yep. Okay, now what?
Now, do you multiply the entire numerator by
7x. In other words, you multiply that, you multiply that, and you multiply that. So this becomes 7x cubed. Well, this becomes 0x squared, because 7 times 0 is 0.
Yeah.
Plus 7x. Now, we can subtract, and everything looks right. Becomes x squared minus 6x. And then what?
And it would just put, it would just be 1.
Okay, plus 1.
Yeah, plus 1.
And then multiply that by everything. You get x squared plus 0x plus 1. Now minus 6x minus 0 is minus 6x. 0 minus a positive 1 is what? What goes down here? Hold on.
Minus 1.
Yes, minus 1, exactly. And now, since you can no longer divide x squared into this, then our answer is that with a remainder of minus 6x minus 1. Hold on a second. I don't like that for some reason. Can't imagine there is any other way to do this problem other than this. We could have factored out an x first. Would that have helped? Oh no. Divide using polynomial long division. I know that if you don't put in a dummy variable there, you run into all kinds of problems right away that I didn't know how to solve. And I thought about it and realized, well, you must need a dummy variable. So possibly the answer is with a remainder of minus 6x minus 1 over x squared plus 1.
Yeah.
And that kind of makes sense if you think about it. In other words, if you're dividing a cubic by a quadratic, you should get a linear term and a remainder if it's not a perfect factor, and it's not. And actually the way I can test as to whether that's the correct answer or not is by multiplying that whole thing by x squared plus 1. Notice what we get. We get 7x cubed plus x squared plus 7x plus 1, and then you have to multiply the x squared plus 1 times this whole thing, so you end up with minus 6x minus 1. Cancel everything out and you get what we started with. So that verifies that we did it correctly. First I didn't like seeing a remainder with a variable in it, but I guess you can have that. So let's have, it's an unusual one to put as number 11. That's, for one thing, that's not, you don't see that problem every day. I've gone a long time before seeing dividing by a quadratic. Alright, let's do the same thing here. We don't need a dummy variable here. At least we don't need it. Yeah, we don't need it. Okay.
You don't need one.
This is more straightforward. Why don't you do this one for me? What goes here?
3x.
Then what?
I'll multiply it all by,
Right here.
so 3x squared. And what do you multiply to find that?
By the 3x. In other words, once you get that first term, then you multiply it by both of the terms that are in the divisor. So we multiplied it by the x to get 3x squared. Now we have to multiply the 3x times minus 5 to get minus 15x. Now what?
No, it's 29x.
Remember, we're subtracting. And one way to remember that is that we have to be subtracting in order to get 0 there. If we were adding, we would have 6x squared there. So we're subtracting. So what is minus 14 minus a minus 15?
1.
Okay. 1x, or just x. Bring down the 5. Now what?
Now you just multiply by 1. 1 would be up top.
Well, yeah, you divide that into that, which is plus 1, and that's what you write there, is plus 1. Now, of course, this is a perfect factor of it, because when I multiply the 1 back here, I get that, and I get a remainder of 0. And you have to have a remainder of 0 in order to divide this evenly into that. If you do not get a remainder of 0, it's not a factor. In this case, it is. And in fact, what it means is that x minus 5 times 3x plus 1 equals what's inside the rectangle.
Right.
Oh, gosh. That 11 is an odd problem to be in there. I wonder if there's a different way to do that. I don't think there is, though. Now see, this isn't strange at all. Show that the binomial is a factor of the polynomial. How are we going to do that?
Can't you do synthetic division?
Yeah. Okay? Let's do it. Tell me how.
So you put 4 in the little shelf thingy.
Okay, in the box, yeah? Actually, you put -4. Okay, let's go over that. If you're going to use synthetic division, and if x plus 4 is a solution, then that means x plus 4 is equal to 0, and therefore the solution must be actually -4. And the other way to think about synthetic division is to realize that if we were doing long division, what would we do? We would do this, right?
Yeah.
But when you do long division, you end up subtracting. So if you're going to turn it into an addition problem, you have to have the opposite sign of the number in the box in order to be able to turn this into synthetic division. So that's one way to look at it. The way I look at it is I always realize that what goes in the box is the solution, not the factor, but the solution. Okay, so what goes across the top?
It would be 1, 10, 29, and 20.
Okay. Now what? What goes down here?
1.
Okay, here.
-4.
Okay, here.
40? -40?
We're adding.
Oh.
Remember, always adding. We're in the same step as we would be in with long division, only with long division we'd be subtracting. So you're always going to be adding these columns of numbers here. So it's, okay, what goes here?
-24.
Okay, here,
5.
here,
-20.
and here.
0.
And that's what I was just saying is that if we're trying to show that x plus 4 is a factor of that cubic, then we must get a 0 as the remainder. Now, they don't ask you to do anything further here, but what is the other factor? In other words, so x plus 4 is indeed a factor. Well, after you divide this cubic by x plus 4, what do you have left over? The synthetic division shows you. It's these last 3 numbers here. Those are the coefficients of the quadratic. It must be a quadratic, because only a quadratic times this linear factor would produce a cubic. So what's the quadratic that goes here?
X squared plus 6x plus 5.
So there's 2 factors of that cubic. It's not fully factored because this one actually factors into x plus 5 times x plus 1. So to fully factor that cubic, we would have to do that. But as far as this problem goes, the only thing we really have to show is that that cubic divided by that linear factor gives you a remainder of 0. I didn't really need to do the rest of it, but I wanted to, just to show you that what you get here are the coefficients of the remaining factor.
Yeah.
Okay. Now, these are all quite normal, which really is a strange result for number 11 to be in this pile.
Yeah.
I don't get it. We may want to go back and look at number 11. I'm curious. I may want to do that on Wolfram Alpha just to verify. I'm pretty sure I did it right. but it was so much harder than any of these others. These others
Yeah.
are a piece of cake, really. Okay, so let's do this synthetically. Tell me where everything goes.
So positive 5 in the little box. Then 1, negative 5, negative 9, then 45.
Yeah, here is typically where you would find dummy variables, is in the higher degree polynomial. In other words, if you were to take out that minus 9x, we would need to put in a plus 0 in place of it. You can't not have one of the degrees of your polynomial. You know what I'm saying?
Yeah.
Okay. Just like I put the dummy variable into the divisor in problem number 11. Because it was missing an x. It was just x squared plus 1. Okay, so
1, 5, 0, 0, negative 9, negative 45. Zero?
so is x minus 5 a factor?
Yes.
It did say, I didn't see the rest of that question. It did say, then factor the function completely. Well, okay, so we still have more to do here. So we got x minus 5 times what?
X squared plus 0 x, or it would be plus 0x, then
So I won't write it.
minus 9.
Okay. It's not quite fully factored. Keep going.
X minus 3 and x plus 3.
Good. Just want to look at this question again. I'm going to put that into Wolfram Alpha and see what it spits out. So let's see, I need parentheses, don't I? 7x to the third plus x to the second plus x, end paren, divide by x squared plus 1. Let's see what they put out as an answer. Alternate forms. See this one down here?
Yeah.
That's what we came up with, isn't it? It's exactly what we came up with. The only odd thing is that Wolfram Alpha puts it in front. In other words,
Yeah.
it's unusual to put the remainder in front. Okay, here's what we came up with was 7x plus 1 minus 6x minus 1 all over x squared plus 1. Well, there's the minus 6x minus 1 all over x squared plus 1 plus the 7x plus 1. So that's the right answer we did. So we did it right. They do also give you a couple of alternative forms. It always kind of amazes me how they factor some of these. Look at how this thing is factored. You see it, the middle one there?
Yeah.
It's x times the quantity 7x plus 1 plus 1. How in the world do they ever come up with that?
Oh no.
You have to group it. Very strange in order to come up with that. This even has some complex roots, has a couple of imaginary roots. All right, is that all you have for tonight? Just those two pages?
I actually have one more. I have one more problem.
Time for one more. Can you read it? Is it the same kind of thing?
It's kind of. It's evaluate f of 2 for f of x when x is equal to, or yeah, evaluate f of 2 for f of x equals x cubed minus 2x squared plus 4x plus 3.
Okay. What is f of 2 equal to? How do I do it?
You just plug 2 in for all the x's?
In fact, whether it's a number or a variable, you plug it in for all the x's. In other words, yes, I'm going to plug it in. So what should I write?
Do you want the already solved form or just?
No, do it step by step.
2 to the third minus 2 to the second.
I think this is a critical step, to be honest with you. Writing it like this, as opposed to doing all the calculations in your head. This one, you could have almost done them all in your head and probably come up close to the right answer. But if I switch that and say evaluate f of minus 2, now you need all those parentheses. So it's a good habit to get into, is to write this step fully out. You'll make a lot fewer mistakes. So now simplify.
So 8 minus 8 plus 8 plus 3.
Equals what?
11.
Okay. Were there more with that problem? In other words, do another f of something else?
It just said use synthetic division.
To evaluate f of 2?
Yeah.
Okay, let's do it synthetically. That's the same thing as synthetically dividing by 2. Let's see if we get 11.
All right.
Now, I'm not sure where the 11 is supposed to show up. I suppose at the end. Okay, let's...
Yeah.
1,
So 1,
2, 0, 0, 4, 8, 11. How about that? I did not know that. That if you want to evaluate a function at a certain number, that you synthetically divide it. Notice I didn't change the sign. I used 2, not minus 2. So whenever you're doing synthetic division, and sometimes it's called synthetic substitution, you could actually call this synthetic substitution, and it evaluates a function at a given number.
Right.
It's the same as the remainder, actually. In other words, if I was dividing this by x minus 2, I would get a remainder of 11. And that's the same as evaluating it at 2. Interesting. That means if I evaluate it at one of its zeros, it's always 0. And I knew that. And that would have to be 0 if we were evaluating it at one of its zeros. Okay, cool. So if we evaluate it at -2, well, that actually is significantly easier to use synthetic substitution. Notice that if I wanted to evaluate f of -2, I'd have to go in there and do this. All those negative signs are kind of a nightmare. Okay, what does that give you? It's -8, and then -8, -8 plus 3, that's -21. So if we synthetically divide it, we should get -21 as a remainder. Let's see if we do. Bingo. Okay. Interesting. I did learn that once upon a time, but I hadn't used that feature very much lately. All right, Mitch, I will talk to you on Saturday morning.
All right, Saturday at 4.
Saturday at when?
4, I thought. Thought we moved both of them to.
I certainly am willing to do that. You want me to do that? I hadn't done it, but I'll do it now. Now, is your Wednesday at 4 or 4:30? She wasn't sure you were home from school by 4, so that's the reason she wanted to do 4:30.
It should be 4 now. I had PT today.
Okay, so we'll make it consistent. We'll make both of them 4. Let's see if it lets me change this one. Hold on. Yeah, no, I do have the other one at 4. Yeah, okay, they're both at 4 now, so I'll talk to you Saturday at 4.